Now, in this video, we will going to take up one more problem, the problem number 66. Determine the changes in length, width, and thickness of a steel bar, which is 4 meter long, 30 mm wide, and 20 mm thick, and is subjected to an axial pull of 30 kN in the direction of length. Change E will be equal to 2 into 10 to the power of 5 Newton per mm square, and Poisson's ratio equals 0.3. Also, determine the volumetric strain, change in volume, and final volume of the given bar. So, the length is given to be 4 meter long, so naturally L will be equal to 4000 mm. Then the B is 30 mm wide, B is equal to 30 mm, and D is equal to 20 mm. And E equals 2 into 10 to the power of 5 Newton per mm square, and P equals 30 kilonewton, so 30 into 10 to the power of 3 Newton, and 1 by m is Poisson's ratio, which is 0.3. So what is change in dimension? The change in dimension, first we are going to take up the cross-sectional area. Area is 30 into 2, 30 into 20, which will be equal to 600 mm square. What is the change in length? Delta L will be equal to P into L by A into E. So as P is equal to 2 into 10 to the power, 30 into 10 to the power of 3 into length is 4000, that is 4 into 10 to the power of 3, divided by area of cross section is 30 into 20, that is 600, into 200 into 10 to the power of 3, which is the Young's modulus. So substituting these values on simplification, you will going to get 1 mm increase in length. So then what is the longitudinal strain, which is epsilon x will be equal to delta L by L, that is 1 by 4000 will be equal to 0.25 into 10 to the power of minus 3. So now, what is 1 by m? That is the Poisson's ratio, which is equal to epsilon lateral into epsilon longitudinal. So what is epsilon lateral, which is 0.3? 1 by m is the Poisson's ratio into longitudinal strain is 0.25 into 10 to the power of minus 3. Substituting these two values and on simplification, you will going to get it as 0.75 into 10 to the power of minus 4. What is the change in width? Delta B will be equal to 1 by m, that is delta B will be equal to epsilon lateral by epsilon longitudinal. So that is delta B by B will be equal to 1.75 into 10 to the power of minus 4 into B, which will be equal to 0.75 into 10 to the power of minus 4 into 30, which will be equal to, on simplification, you will going to get it as 2.25 into 10 to the power of minus 3 mm, which is decrease in length, and delta D, again change in depth or thickness, will be equal to, again delta D will be equal to epsilon lateral into D, that is 0.75 into 10 to the power of minus 4 into D, which is 0.75 into 10 to the power of minus 4 into 20, which will be equal to 15 into 10 to the power of minus 3, which is again decrease in depth or thickness. What is the volumetric strain? Volumetric strain epsilon B will be equal to m sigma by E into 1 minus 2 by m. So what is that? Epsilon x sigma by E is nothing but epsilon x into 1 minus 2 by m. What is epsilon x? Will be equal to 0.25 into 10 to the power of minus 3 into 1 minus 2 into 0.3, which is 10 to the power of minus 4. So what is the virginal volume? L into B into D, which is equal to 4000 into 30 into 20, which will be equal to 24 into 10 to the power of 5. Therefore, volumetric strain epsilon B will be equal to change in volume by the virginal volume. So delta V by V. So what is, we have the delta V, which is volumetric strain epsilon V is 10 to the power of minus 4 is equal to delta V by V, which is 24, delta V by 24 into 10 to the power of 5. Therefore, change in volume will be equal to delta V, which is 240 mm cube, which is the finally, since it is positive, it is increase in volume. Therefore, the final volume will be equal to V plus delta V, that is 24 into 10 to the power of 5 plus 240 will be equal to 2400240 mm cube. So this is how you will be able to solve this problem. So next we are going to take up the one more problem, which is problem number 67. A steel rod of 4 meter long and 20 mm diameter is subjected to an axial tensile load of 40 kilonewton. Determine the change in length, the diameter, and the volume of rod. Take E is equal to 2 into 10 to the power of 5 Newton per mm square, and the Poisson's ratio equals 0.25. So the length is given to be 4000 mm. So D will be equal to 20 and P is equal to 40 kilonewton, which is 40 into 10 to the power of 3. Young's modulus E is 2 into 10 to the power of 5 Newton per mm square, and 1 by m equals 0.25. So what is the original volume, which is pi d square by 4 into L. So pi by 4 into d square is 20 square into length is 4000, which will be, on simplification, you will going to get it as 1256637 E.06 mm cube. So what is the change in length? Delta L will be equal to P into L by A into E. So what is that? P is 40 into 10 to the power of 3 into 4000 divided by pi into 20 square into 2 into 10 to the power of 5 by 4. On simplification, you will going to get it as 2.5465. Since it is a positive value, it is increase in length. So 2.5465 mm. So what is the longitudinal strain? Epsilon x will be equal to delta L by L. We know the value of delta L, which is, substitute that value is 2.5465 by the length, which is 4000. On simplification, you will going to get it as 6.36625 into 10 to the power of minus 4, which is the longitudinal strain. So what is 1 by m? Epsilon lateral into by epsilon longitudinal. What is lateral strain? Epsilon lateral will be equal to 1 by m into longitudinal. 1 by m is 0.25 into longitudinal strain is 0.63, that is 6.3662 into 10 to the power of minus 4. So substitute these two values, and on simplification, you will going to get it as 1.592 into 10 to the power of minus 4. So also what we know, that is the lateral strain will be equal to delta D by D. So what is that delta D? 1.592 into 10 to the power of minus 4 is the lateral strain, equals delta D by D is 20. So on simplification, delta D will be equal to 3.184 into 10 to the power of minus 3 mm, which is decrease in diameter, because it is the load is applied along the length. So naturally the lateral dimension will going to decrease. Similarly, the volumetric strain epsilon B will be equal to epsilon x into 1 minus 2 by m, because it is the diameter. So what is epsilon x? That is 6.3662 into 10 to the power of minus 4, because epsilon x is nothing but delta L by L. You know delta L and L, which we have already calculated from this particular equation. That is delta L by L is 6.3662 into 10 to the power of minus 4. So naturally you will going to get that into 1 minus 2 into 0.25. On simplification, you will going to get it as 3.1831 into 10 to the power of minus 4, which is the volumetric strain. Also, we know what is that volumetric strain? Change in volume by the original volume, which is delta V by V. So delta V will be equal to epsilon V into V. You know epsilon V, substitute that value 3.1831 into 10 to the power of minus 4 into volume is pi d square by 4 into L. The value what you got from that is 1256637.06. So on simplification, the change in volume delta V will be equal to 400 mm cube. Since it is positive, it is increase in volume. So this is all. You will be able to solve this particular problem. If you find this video is useful, kindly subscribe to my channel. Thank you.